Hello, welcome back. This is Lecture 5, page 4, Applications of Composition Functions. So, after t hours of an operation, an assembly line can produce x is equal to f of t, 20t minus t squared over 2 units of a product. So we have one function in terms of time. We can figure out how many units are being produced. But the cost is in terms of the units. So the cost is going to be 100 plus 50 units. So the question is, what is the cost when the assembly line has been operating for 2 hours? So what we're going to note here is that when t is equal to 2, which is in terms of time, we must find x. So what we see is that x is equal to f of 2, because we're going to operate the machine for 2 hours. We're going to produce some units from this. So that's going to be equal to 20 times 2 minus 2 squared over 2. So that's going to be equal to 40 minus 4 over 2. So that's going to be 40 minus 2, which is equal to 38 units. Now to figure out how much that's going to cost us, we need to figure out what the cost function is going to be for producing 38 units. So thus, the cost is going to be 38 units. So I plug this back into the cost function. That's going to be 100 plus 50 times 38, which that's going to be equal to 100 plus 1,900, because that's what 50 times 38 is, which is equal to $2,000. So what we see is that after 2 hours, it's going to cost us $2,000. Okay, so notice what the input is. We first put in time into how many we make, and then we figure out how much does that cost us. Now the next question says, can we put all this together into one nice simple function? And the answer is yes. So first, note that we have the cost is going to be, which is c of x, which is in terms of the number of products sold, which is equal to 100 plus 50x. That's going to be how much money it costs. And the number of units that we have, x is equal to f of t, which is equal to 20t minus t squared over 2. That tells us how many units we're going to make after a certain amount of time. And we can put all this together. So the cost in terms of hours. So that's what we need to figure out. And it's actually really simple. All we're going to do is we're going to put this function x inside the cost. So c of x is equal to c of, which remember x is equal to f of t. So it's actually a composition, because those two are the same. So that's going to equal to the cost in terms of f of t, which f of t was 20t minus t squared divided by 2. And our cost function here, whoops, I should have done that in blue. So our cost function is going to be equal to 100 plus 50 times our inside function, which our inside function we said was 20t minus t squared over 2. So if we expand that out, we're actually going to get 100 plus 50 times 20 is 1,000, so that's going to be 1,000t, minus, and again I'm just distributing this through, 50 divided by 2 is 25, so that's going to be minus 25t squared. So now, if I want to know how much it's going to cost per hour, now I have a new formula using composition. So it's really basic to actually use these applications for business.